When do we start, Deepthi? Let's wait for a couple more minutes. I think so we'll get started. Yeah? Awesome. Nice and bright. So how many of you here are still working in some shape and form on Azure? All of you? All of you working on Azure? Yeah? Okay. Working on storage? Okay. Cool. Why are you here for the session then? If you're already working on it, what's there? Right? Better performance? So you don't like the storage performance? Okay. Good or bad? Okay, so you want to see how you can improve storage. Okay. How many are here thinking that it's going to be some sort of introduction to storage? Anyone? Okay. I think so. I didn't disappoint you on the topic. It says inside Azure storage with a fundamental assumption that you already know something about storage. Okay. That's something that I'm going to assume quite a bit. Okay. And guys at the back, especially, I think so I'm not able to see you. And then you have the advantage of wearing a specs, so I don't know whether you're sleeping. That's my next problem. I'm completely vegetarian, okay, during the session, so you can just come to the front. I don't bite, I don't pound on you. So you could come to the front, you can sit here, ask more questions, okay? And in this session, I'm going to ask you a lot more questions because you guys have already worked. Okay, so there are a lot more questions coming from this side rather than coming from this side. Okay, so that's going to happen. Good. Yeah. Still the backbenchers are thinking, okay, right. Yeah. Should I run off to the next session? Is that what you're thinking? Good. Let's get the timer on. Wow. Is there a tea outside? At this time? Is that a tea? Okay. No wonder I see a crowd there. Good. Who's coming here for the second Azure conference? Both the conferences? Oh, wow. No, not last year and this year. Last year and this year. Lee Meridian in Bangalore. So how many were there in the Bangalore one? Bangalore? Okay. How many attended my Bangalore session last year? Anyone? No? Okay. Last year was a completely SQL session that I did. So I was talking about SQL Server performance on top of Azure. I don't think so that topic is there for this year. I think so we just spat it away. I was thinking, what topic should I be talking about? And it was a huge contemplation for quite some time, talking about, okay, right, we could talk on so many things. I mean, like Azure has got so many services around. I'm a hardcore SQL guy. I can still talk on SQL. I can talk about SQL Azure DB on the other side. I can talk about IIS on the other side. Then I took a step back and said, okay, these topics are known. Most of you know it. I think so there are enough and more people in the industry who have played around. So I said, let me take a step back and then talk about something which is different. Okay, so the idea over here is that I want to talk to you what I talk to our customers. Okay, so my name is Vinod. For the folks who don't know me, I'm a technical evangelist at the Microsoft Technology Center. So what we do is help customers solve their problems. That's exactly what we are. So the MTC team is quite around. So if anyone attended Anand's session yesterday, then Anand is a product of MTC. So I'm part of the MTC. Anyone attended Govind's session? Govind and Hemant's session yesterday? Yeah? So Govind is my technical director for all practical purposes. So all of us are from the MTC. So we are heads down problem solvers. So that's what we are. So when the topic was, when I had to suggest a topic for the Azure conference, I said, hey, let me give you something which is more on the practical side. Let me tell you what I've gone through, what I tell customers, and what are these experiences. That's what this is all about. So about me, I'm an architect. I'm a father of one daughter, a husband of one wife, as on date. I've written a couple of books, and I do speak at conferences, okay? That's what I am. Somebody might have a few variations of this as part of introduction, so I'll just leave that. Cut the marketing. Let's get back to the work, okay? So what am I going to do? What are your session objectives? What is our plan over here? End of the day, it's about learning. It's about experiences. I think so the best thing that I've always seen is that the learning doesn't stop. The learning gives you experiences, and the experiences give you good judgment over the day. That's exactly how it is. And all of us are running behind deadlines. I don't think so there's anybody in this room who will say that I don't have a deadline that I have to meet, right? So it is about running behind deadlines, but you'll have to be much more cognizant about how you go about playing this deadline, right? So there's a lot of learning that is going to come. There's a lot of learning that I'm going to share. Maybe give you a few intros to start off with, and then get into the deep meat of the session in about 5 to 10 minutes. So most important thing that you need to understand, our storage is the backbone for Azure. So you like it or not, if you're using any part of Azure, I think so there is a storage behind it. We got to give you something. We give you a VM, it comes from a storage. We attach this, it comes from storage. You talk about blobs, it comes from storage. You put on queues, you come from storage. You attach a web role, it's a storage. You attach a worker role, it's a storage. There is a storage component everywhere. You like it or you don't like it, right? I can't just give you performance. I can't give you machines out of thin air. I got to store it somewhere, and that's where storage is important. But the most important thing is that we got to look at, like most of you have come back and said that, hey, I use storage, but I'm looking at performance. I'm looking at strategies for performance, okay? And you got to go ahead and start designing for it. So this session will fuel that quite a bit. I've seen customers come back and then talk about this concept. They say that, hey, I have this, I'm copying files across servers, I'm doing a whole bunch of things. If I don't have space, you get this. All of us have our laptops. We have no depth of data. That's a good part of it. But the point is that we got to understand how we play with this data, right? So when you talk about your laptops, you have some constraints to play with. But born in the cloud, as today morning, if you saw Srikanth and others talk about it, I think so. This storage of data or the storage is becoming omnipotent, or for most cases are being taken for granted. So what am I talking about? When I sit inside a single subscription, I'm talking about a lot of data that I can put. Just my subscription. Forget about anything else. Count the number of zeros, you'll be zapped. And if you can tell me how many zeros are there, you can tell me how many zeros, but what do you call this? Right? Yeah? It's a petabyte? No. It's a zettabyte. Okay? You have it. I mean, like, see, there's nothing like infinite. There's something finite. But if you have infinite money, then we have infinite storage also. Right? It's a very simple concept, okay? It's about how deep your pockets are. That's how it is. That's how vendors were playing that game, right? So storage is becoming really omnipotent everywhere. And it's important for us to go ahead and understand why this is. A lot of them question about our storage. And I think so I want to just demystify some of the things, okay? I want to be very much clear about it. Cloud storage, I think so cloud storage has been there in the industry for quite some time. I think so the commoditization of the storage started to happen as soon as you had services coming on top of them. You had, what do you say, the Dropbox of the world and the other worlds came back and said, hey, you have this concept. I said, guys, if you didn't know it, OneDrive has been there for quite some time. SkyDrive has been there for quite some time. Google Drive has been there for quite some time. I'm like, what are you talking about it, right? It's about building services which are much more competent and enterprises that actually make and tip it out. You're talking about a highly durable storage. You're talking about availability. You're talking about all that. You're talking about trillions of objects. This is dated about 6 months back. You're talking about 2.5 million requests per second coming and landing on top of your storage. Huge that we are talking about. So don't question our scalability. Scalability is taken care. Okay? A lot of times it's like a kid. I mean, like, I've seen this. How many of you have heard this phrase? I mean, like, it's like taking a candy from a kid. Heard of it? I have a 2-year-old kid, okay? I understand how difficult it is. Give me a break. I mean, don't question it. I mean, it's done at scale. It's not done in small pockets. I mean, like, we're not talking about an SSD and just putting it on your disk. We're talking about scale here. Scale in a different order of magnitude. That's what we want. And you can't question it. You can't literally question it. Pay for what you use. I think so. This is, I mean, like it's prohibitively, or if you see some of these SAN vendors, if you're looking at it on the storage space, it's prohibitively expensive. From if you really look at it for price per GB that you have for on premise, and then your operational overheads on top of it. But we are talking about at a different level. Pay per minute. I think so that dynamics totally changes in a lot of ways. Why performance and scalability? I think so that's the topic, because every customer I go and meet, and I think so this is what I've seen. Every customer, every developer that I go and meet, the first thing they come and ask is performance. They say that, hey, I want you to tell me how I can be performant on top of this. Okay, it's a taken. So our way of looking at it from an MTC is to just go ahead and tell you a very simple thing: do it the right way. I want you to do it the right way, and I think so this session is all about that. There are a huge amount of code blocks that I'm just going to show you, okay? And I'm just going to, all I want you to is to pick the queues. That's more important. Because I'll tell you, if I go and start writing, okay, how do I connect to a blob storage or a queue storage? Irrelevant. Go, please look at MSDN, because it's already there. I don't want to puke out what MSDN is going to tell you. I want to just tell you what our customers are making mistakes, what I have learned from those mistakes, and then I'm giving it back to you so that you don't have to make those mistakes. Okay, so there's a lot of things that I'm going to give you as concepts that are going to come. So as developers, we do not want you to fall the same pitfall that many of our customers have already done. And that is the goal of the session. Okay, next 40 minutes that you're going to be with me. It's about the experience that I've gained over the years. And if you make these small changes that I'm going to talk about over the session, the next 40 minutes, you are going to see that you're going to get huge amount of improvements in order of magnitude. You will be surprised. Okay, it's a huge amount of. So I want to talk again. Big thing. If you're really talking about it, I think so. We have increased our storage from a subscription perspective. Each account can go up to 500 TB of utilization. Obviously, you can go ahead and bump that up to a higher scale. But you're talking about TB is quite a lot of storage that we're talking about. Okay, millions of transactions, trillions of objects that are actually sitting on top of Azure. So forget it. Let's go ahead and optimize our applications to start maximizing what is available over there. Cloud is all about dynamics. There's a lot of dynamics. There are a lot of choice. I think so. Freedom from choice and freedom of choice. That's what Mark was talking about. I think so. We have a lot of options now. Okay, and that's exactly what it is. Today, I know in the morning I was talking to a bunch of MVPs who was out there, and they were saying that, hey, how do I store? How do I start using SQL? I said that, hey, hold on. I'm a big-time SQL fan. So if you come to me, I'm going to tell you SQL Server, but you don't have to use SQL Server. You have other choices. You have DocumentDB. Have you evaluated what DocumentDB can do, and why should I be using DocumentDB instead of using a SQL? Or can I use a blob storage instead of a SQL for logging? Can I use a table as a characteristic? Why? I'm talking about 12 cents, which is way cheaper than going into a relational database where I need to have a whole lot of different dynamics to play with. Cloud, you're coming in to save cost, and I'm here to tell you that how you can save cost. Okay. Let's talk about some of the abstractions. I think so. You know all these abstractions. I'm not going to talk about these because they have been there in our market, right? There are fundamentally four different abstraction blocks. These are basic fundamental building blocks. The latest that got into our arsenal is the Azure Files. How many of you using Azure Files? Used it? No? Heard about it?
Yes.
Wow. How many of you are web developers? How many of you are using IIS and all that? How many of you are having your IIS metadata file? How are you actually going ahead and having a single metadata file for all your web forms? Can you do it? Have you ever questioned that? You're trying for that, right? That is your answer here. That is your answer. You had this. You had this for 6 months. You could, see, end of the day, look at it. So here's how I see it. Don't look at it as a feature enablement. Look at it as a solution that you will fall into. Okay? And if you didn't have it, you had ways of doing it also. Okay? I could have done this in the earlier versions also. Just that we didn't use it that way. Okay? So I'll tell you how things are. So blobs, how many of you are using blobs in some capacity? If you're using storage, how many of you are using VMs? All of you are also using blobs, so in that case. As simple as that. Okay? So the answer for this is very simple. Whenever I ask you a question, all of you can raise your hands. If you are working on Azure in some capacity because you're using it. Just that we don't know that it is using it under the hoods. That's about it. Okay. So blobs, both of page blobs, or if you're going of a standard blocks, which is nothing but end of the day is going to be an attached storage that you're having on top of a VM. I think so you are using both the capacities of a blob. End of the day. That's it. Files, it's based on the SMB architecture. If you have heard about it, SQL also supports SMB architecture since SQL 2014 onwards, which is nothing but you can start having your files on top of a file share, right? And SMB file shares were very prominent in the local, what if you say, data centers. A lot of people had files that were kept on a file share, and then they collaborate on top of it. And machines wanted to have a centralized place for doing some things. What? Logging, for example, auditing, for example, events that you're actually putting it. All these are classic case and points scenarios where you wanted a centralized share and then you wanted to do this. And obviously SMB file share and files, Azure files are taking you in that direction. Okay, so that's exactly the place where you're going to look at from a files perspective. Tables have been there. How many? Okay, this is a very classic example. How many of you use tables in the sense Azure tables in your applications? I see one hand. I just see a few of you. Why not using Azure tables? It's the toughest of the lot, actually. Sometimes. How do you go ahead and I mean it's the easiest of the lot from a NoSQL point of view, from Microsoft's offering. But it is the toughest of the lot because you got to go ahead. You can make a lot of mistakes when it comes to Azure tables because it is a NoSQL variation, right? You will make a lot of mistakes, especially the way in which you query it. You queried it suddenly so slow, and then you say, boss, there are only 3 rows coming in, and then you're taking like what, 2 minutes to do this? Something wrong, right? I say that no, there's nothing wrong about the storage. The storage works that way. Now, you got to understand how should I be calling the storage, or have I designed it for that query pattern? That's my key, right? Okay, so I'll talk, I think the predominant of my session is going to be around the patterns that are going to come out of this, okay? Table partitioning is one of the most toughest choices that you will have to get your heads around with. But I'll tell you some customer scenarios that we have used, just giving you some patterns around that, okay? Queues, I think so, are useful. I'll give you a pattern around for the queues perspective. Okay, so quickly jumping around. For centralized access mechanism, you could have gone ahead and taken a small VM, put a share on top of it, and if it was on the same VNet, you could have started and done this. So if you are having an IIS sort of a configuration, I could have done this earlier. That was already there. It's a standard pattern. You need a file share. The only way that I can do is I can't give you a file share which is like centrally on the blob. The only way that I could have done is that create a VNet and then put a VM on top of it and give it as a file share within my network. So obviously you will create it and then you will use it. You could have done this. So you don't have to actually break your head on top of that. It's far more easier. I mean, obviously if you've used Azure websites, you have a different level of consistency that you get, but I don't get the flexibility that I want if I have to load a module or a HTTP module or something of that sort. That defeats the purpose of actually going the website route, right? Am I clear? All of you in sync with me? So you have choice, but you got to know where is my slider of this flexibility that I want and the customization that I want. So high customization, this thing I'll go on using a web role sort of a route. I don't want customization, I want faster. This thing I'll go through the website sort of a route. But obviously the middle ground will come in. Okay, so don't worry, we are doing a lot of investments on this. I think so you'll see a lot of this. So from that, we moved away and said that, hey, okay, we do understand customers want this. They want a centralized share. They do not want to, see, end of the day, look at it. If you put things on top of a VM, it actually goes to the same level of abstraction every time when I go in and access it. There are 3 levels of abstraction that I have to go through. I've got to go through the front end, I have to go through the partition, and then I have to go through the actual data stream that I'm actually bringing in. Now, if you load it into a VM, I move to the same partition layer, and when I go ahead and touch my other VM, I go through the same 3 partition layer. I'm not accessing the data as is straight. That was my problem. So if you jump up the stack of networking, you're actually incurring a lot of huge cost. Okay, so I don't want that to happen, and we wanted a way to give you much more of an elevated way of seeing this, and that's why Azure files were brought in. Okay, So huge scenarios that you have, you want to share data across VMs. That's a classic scenario. Blobs, logs that you want, auditing records that you want to go ahead and keep it. All this are classic scenario because you don't want to bind it to a VM. Okay, and at the same time, I don't want to miss out on my log if the log gets, if you have to say if the machine gets restarted. If I store it locally, and I've seen a lot of people make this mistake. Do not use your D drive. How many of you are ever using your D drives? Do not use them. Why do you have to use them? If it is a completely transient sort of a data sets, I will use it. But the biggest problem for me is that, like for example, I've seen people go ahead and put their SQL Server, TempDB and others onto a D drive. Has anyone done that? Please do not do it. Please do not do it. Okay, biggest thing. Okay, the reason is very simple. As soon as you do that, when the VM gets, because the point is that the D drive need not have to come, D drive need not have to get attached till my whole VM comes up. Which means that when my VM as soon as comes up, my SQL Server service would have started. As soon as my SQL Server service starts, it starts to see master, and then the next database is TempDB. So as soon as it comes to the TempDB, it sees that I do not have the D drive attached to me because that is taking its own course of attachment. Since that is happening from the OS layer, I do not have control on top of it. And if I cannot find my TempDB location, I will not start up. That's my problem. Huge problem. I mean, so you got to be very careful around how you go around playing with this. Okay, so it's very important. Okay, so all that, those were all the general sharing that I wanted to tell you. Okay, all of you understand what are the storage units and a whole bunch of things. So here it gets into hardcore internals next. Okay, so I'll tell you what happens behind the scenes. If you understand what happens behind the scenes, I think so you will start coding for behind the scenes. So your coding becomes far more efficient. So that's the whole idea. Okay, so the next 5-10 minutes is mostly around the internals, and then the whole bunch of tiers that I'm going to talk about. So what does storage layer consist of? Storage layers consist of 3 different distinctive layers. Okay, as you have built your own 3-tier architectures, we went ahead and built our own 3-tier architectures on top of this. Okay, there's a front-end tier, there's a partition tier, and there's a storage tier. Okay, so end of the day, whatever happens inside is that whenever your request comes in, the request comes and lands into a front-end tier, and then it goes ahead and says, hey, you asked for this request. I'm going to see where is the partition, or which is the partition which is holding your data. Okay, so now understand, now when I use partition, now you can also associate the same thing with your partition keys that you're doing. Okay, from a table, it can be a partition key. If it's a standard blob, it can be a blob URL. So every blob URL is a partition. Okay, so when I land into a request saying that, hey, this is what I want from the storage tier, this goes and says that where is this stored? Who is going to serve it? So each partition is a unit of work, and it is in its own single entity or held inside a partition. Partitions cannot be scaled. So data inside a partition cannot be scaled out, but storage of each of the partition can be scaled out across partitions. So I can have data of different files, or I can have a single table which are partitioned in different users. Each of the users will land into a different partition. Okay, and they'll be stored in different partition or streams. That's how I store it. Okay, so I can scale out within a partition based on different entities, but within a partition key, I cannot scale out. Okay, that's the key over here. Okay, so that's the fundamental crux. And then you come down to the storage stream. How many replicas do you have? How many? 3? Is that a question or an answer? That's an answer. Okay, 3 locally and 3 geo-redundant. So it's in a sense it can be 6, which is 3 asynchronous copies and 3 locally redundant copies. You got to understand some of the dynamics of it. Okay, whatever you write into a stream is at any point in time synchronously replicated 3 times. But when it comes to the geo-replication, it works slightly different. Each of your workloads can be different. Classic case in point. SQL, for example. Again, I'm bringing back SQL because SQL, I'm a SQL guy. I mean, I've written SQL as a champ here, right? I'm a SQL guy by heart. SQL doesn't like asynchronicity. SQL is bad on asynchronous. SQL always writes what we call as write-through writes. Which means, how many of you know that you can have caching on your data disks? Use caching in your data disks? There's a small checkbox that comes when you create your account and then when you attach a disk and all that. SQL doesn't like caching. Okay, and if you have it, you can have up to a maximum of 4 disks that can be actually given for the write cache, out of which C: is already a write cache enabled, so for all practical purposes. So which means that you can have 3 other disks that can be write cache enabled at any point in time. Do not use it for SQL workloads. Do not use it for SharePoint workloads. You can use it for other workloads. And if you're using analysis services running on top of it, fair enough. If you're using some sort of reporting tools and Tableaus and other things you're running, use it. If you're using SAP's front-end tools, use it. Those are optimized in a different way. So you got to look at what workload comes in and how my attach and how my each of these caching work. It's very important and critical. Please take a note of that. Okay, so let's talk about it. This whole session is fundamentally all about partitions. Okay, if I understand partition, because partition is the fundamental building block of access to my storage. Now, as I said, everything that you have inside your VMs or VMs or any service that you're having is fundamentally a partitioned data. That's about it. So I'm not going to distinguish when I talk about streams or when I talk about partition. I'm not going to distinguish you between, is it a VM, is it a table, is it a blob, is it a page? I don't distinguish. End of the day, there are a bunch of disks that are there, like a farm that is available, and I'm just utilizing that for each of these services. Got it? Yes? So, as I said, I think so. A single partition is an atomic entity of the partition key, which means that in its whole entirety, I can atomically update that partition without compromising on data integrity. Data integrity is taken care because I take your partition key and say that this partition key can be only surfaced or used by this partition server. All this time, a lot of times people come back and say, you're coming and telling me that, hey, you have 3 different copies. Does this 3 different copies at what time? What's the latency of it? I say, I don't care. Because what is the function of a partition server is to make sure that you have to write 3 copies. He doesn't care where he's writing it. But the partition server takes care of the fact that he's written 3 times before he sends back the request. Got it? It is partition server's point of view, you'll have to look at it. So it's very important that we understand this. That's the reason why it is not, as soon as you access the storage, you're not directly going and accessing it. You're going through this layer. Okay? So you'll have to be very cognizant about it. So let's go through a few examples. Simple examples, just to illustrate you what happens. So a request comes, he says that, hey, I want partition F. I'm going to go ahead and point you back to a partition, which is partition number 3 over here, and that takes you to a stream out there. Okay, so which is, I can bring you data from any of your 3 replicas. I don't have to actually worry about which replica I'm bringing you from. How many of you have got errors while accessing your replica or accessing your storage? I'm telling access of storage. If you're getting a 503 error, there's a different error. You will not. A 503 error is a throttling error that you would get. You can get a throttling error because the number of requests that are coming cannot be served by that partition layer. Then you will get a request, you will get an error over there. That's a throttling error because I have to cap you. Because understand, this is cloud. This is not a server that is sitting in your data centers where I can just go and plug in that network cable and put a fiber optic there. I can't do that, right? So, temporary unavailability. That is okay. Temporary unavailability, keep that in mind because I'm going to show you a scenario of that. Because it is completely dependent on our design. If we do a wrong design, you will get a temporary unavailability. Okay? So you have caps on it, right? You have caps on bandwidth that you utilize, and you have caps on each access method, right? If you're on a table or a blob, it's more than, if you go ahead and access more than 2,000 entities per second, I will cap you. I will not allow you to do that. Now, how do you get an elevate away from that? It is not the amount of, okay, I'll talk about that, okay? Let me show you this in an illustration, okay? That's the first type. So you have the second request come in, it goes ahead and says that, hey, I need partition F, but I need a different storage stream. I go ahead and go through the same, I can go through the same front-end layer, or I can go through any front-end layer, because front-end layers are load balanced. I have a scale-out mechanism from an access request perspective, but I will block you from the access pattern on the partition layer. That's how I will do it, okay? Because the streaming layer is much more hardwired. Now, that's a classic example of going to the same partition but coming from a different front-end layer. Now, if you have other ways of looking at it, if you go ahead and say that I want a different partition all by itself, obviously it's a different request. So each request actually goes through its own load balanced front-end servers, goes through the partition layer that it wants to, and then gets into the storage. I think so. This is no rocket science, mind you. I think so. You guys have been doing this for ages. How many of you know about application-based partitioning? If you have heard about it, it used to be there in quite a lot of this thing. So, like for example, you have a football or you have the cricket or this thing. You have systems that are sitting wherein you want to make sure that this section of this audiences can buy the tickets for the sports without bothering what this section is doing. So I would say that, hey, you want this premier seating arrangements, I put them all onto one server and say that whenever you come and ask for a premier request, I'll go to this side of the database. That's the only way I could have scaled out my database. Databases don't have the concept of scale out. They have a scale up. You keep on adding RAM on top of it. You add storage on top of it. That's how we always do. But application-based partitioning went ahead and demystified that. They demolded that whole concept, right? So you have been doing this. I'm not talking any different rocket science. And you should need to understand this. If you have a batch request, and I think this is something that I think a lot of you would be doing if you're using storage in some capacity, either on the tables or on the blobs, have you access it. So what you do is that if you access data across properties, then what will happen is you'll go through the same storage layer. Storage layer will say that, hey, which is the partition that has to be served, because based on my partition key over here, which is W, but you need more than one entity, so I will go back and then I will scan on the stream layer. Okay, so partition scans, there are two things that can happen. You can have a partition scan or you can have a table scan. Just like any SQL construct that you would do, right? The worst is the table scan. Because you obviously know, because you have to touch each and every partition and every entities that are sitting inside that before to satisfy your query that you have written. And only on those cases where you will get this unavailability part of it. Because you're scanning more than, see, understand, it's not just this one request that is going in. You can see, how many of you have done reporting services in some capacity? Yeah? You would see that when you run an MIS query on top of your database, suddenly all your transaction workload goes down. Why is that happening? Because the number of logs that are taken by your MIS system, which is running on a huge aggregation, is actually depriving you of the number of logs that you have that can be taken at any point in time. As I said, I have throttling limits at every place, which means that if I exceed my 2000 objects, entities touched per second, because just I have one badly written query, I will make sure that nobody else gets access. So you'll get temporary unavailability of that. So it's a problem in our design way that we look at it. So what are some of the patterns? So look at it. Partition keys is the most important thing that you will have to look at. So what is the partition key for a blob? For a blob, it's the full path. So that's my key. So which means that if I point you to a blob path, it goes to always a single partition. Got it? My scalability of my partition is always limited. Okay, that's always the case. Okay, tables is the partition key, for queues is the queue name, and for the files it's nothing but the file share. Okay, so it's a very simple concept. I think so. Everything else that you do inside Azure comes and falls inside this bracket, somewhere. Fair enough? Yes. Any doubts on this? This is the internals of how it works. Okay. Now, what I'm going to do next is a very simple thing. Okay. Now, how do you go ahead and start designing for this for these from a performance standpoint? So the next 15-20 minutes that I'm going to talk about is a whole bunch of things. Just take a cue of it, and then I think so you will have a better understanding of how storage works. Okay, so if you understood what partition keys are, what are streams, and how front ends work, I think so it's all about going ahead and manipulating this whole concept, and so that you can maximize on top of it. Okay, so let's understand Tables are the most difficult part from a partitioning perspective, because there are multiple ways of skinning the cow. So over here, I'm going to just take table as an example, and then we'll look at the various query patterns on top of it, and then we'll say what could I have done differently so that I could have got a better performance. Fair enough? So in this example, it's a very standard example. You go for a table structure. A lot of us go ahead and do this. In this particular case, the partition key is nothing but the users that are there. It's a fair call, because we are always tuned to the fact that this is how we did it in SQL. Okay, we took entities and then we say that, hey, this is the user and this is the order for this user. And then we have this natural tendency of using user ID as a classic example of primary key. Go ahead and create a row key based on accounts that are there, and then obviously you have different entities and properties that are there. But how many times do we go ahead and query on top of entities versus how many times do we go ahead and query on top of the properties? The probability is that you go and query on the properties a lot more higher when compared to the number of entities. When was the order done? You don't go ahead and say that, hey, give me all the orders that were done by Vinod. Is that what you do? Rare, right? But give me all the orders that were done yesterday. Or give me all the orders which were of value more than 10,000. Give me, all that is what you're doing. You're always working on the property set rather than not working on the entity set, right? So you got to keep a close eye on how is your pattern going to be. It's very important, okay? Now that we got the structure very clear, but in a table storage, each of them is a NoSQL variant, which means that the properties do not have to be the same across your entities, okay? So here's a classic example of a query pattern, okay? Very simple pattern that we'll take, and then this is just the sharing of the patterns that I have. So you have a bunch of pattern over here. The pattern is very simple. I went ahead and said that, hey, I have a state, and then I have a city, and then I have a population of each of the cities, okay? And how do I do query patterns on top of them, okay? Very simple. The first one, I want all the cities in India from Maharashtra where, give me the population of Mumbai. So I've gone ahead and given you the PK and the row key, which means that this is nothing but a point query. So at any point in time I access a point queries are always the fastest. Because you go directly because you exactly know which is the partition that I'll have to go to, and then from there I know exactly where to pick it from. Okay? Same with the case with any of the providers. I don't think so. This is a very common concept. Okay? Not a big deal. Now let's do a variation of that. I'll say that, hey, give me all the cities in Maharashtra which have a population greater than 1 lakh maybe, or 10,000, whatever it is. Okay? Now what happens is I go to a front-end server. The front-end server says that, hey, you're asking for Maharashtra, so I know my partition key where I should go through, but I don't know how many entities are going to come out of this. And if I have all the entities over here you're doing what we call as a partition scan. So you get to a partition, your scalability is limited to the amount of entities that this partition can serve. Okay? Let's go to the third variation. Give me all the cities in India which are actually having a population more than that. Now, this is a table scan, which fundamentally goes ahead and says that I know that I come to a front-end server, but I'll have to go through all the partitions that are actually holding the population of all the Indian cities. And then from there, I will go to do a partition scan. Yes, partition scans scan more and more entities. And even though the number of records that come in are very low, this one takes literally a whole lot of time. How many of you have experienced this? All of you have experienced this. So now this is a fundamental, there's no flaw on this, but actually this is a very common thinking because we come from the relational world. Okay? And that's why it's a very tough thing to do. So it doesn't matter the number of entities you return. It's the number of entities you touch that really matter. Okay? So end of the day, how does SQL work? It's a very simple concept. I mean, not SQL. I mean, the storage engine works is very simple. I cap you on the number of entities you touch, not on the number of entities that I return. So even if your number of rows returned is just 1, and if I have touched 1,000 entities, your entities per second that you have touched is 1,000. Doesn't matter to me because I've scanned it. So I need to look at innovative ways of actually going ahead and breaking this mold. I cannot just do that. Okay, so avoid scans. It's one of the simplest things that I could have told you, right? How do you avoid a scan? Right? I'm a SQL guy. As soon as I thought that, okay, hey, there should be an innovative way of doing it, right? And I will have to look at ways I can go ahead and break this mold. So the best way that I've always seen, if you're coming from the database world, you can use some of these learnings. So the first learning that I took out was how can I avoid scans? Is go ahead and break my understanding about normalization and say that, hey, go ahead and denormalize your content. You will never hear this from a database guy. But if you're an application developer, you can start thinking about it. Because denormalization is like a huge cost and a whole bunch of things, and then you say that, okay, you're wasting space of your database, you're doing all that. All that is good, yeah. I mean, but think about it. 1 GB of a SQL Azure, 1 GB of a storage, I'll be paying peanuts on this side. So it's okay, storage is cheap. I mean, I don't sweat it out a lot when I'm storing it on my storage. So if I can denormalize it based on my query patterns, then I'm better off of doing the denormalization risk rather than doing a entity scan. So let's put that into perspective. How am I going to do this? Okay, the same thing that you have a bunch of partitions keys that you're doing, okay? And before denormalization, you go ahead and say that I need all the cities which are more than 1 million or 100,000. And then you're doing a partition scan, which is nothing but a table scan, because you're running across partitions and running across the streams, right? Now, how do I go ahead and change this? So I said that, okay, let me understand what your query pattern is. Your query pattern is very simple, right? You're saying that you want to base it based on a population size. So can I go ahead and denormalize my key in such a way that I can go ahead and add additional entities wherein, based on my query pattern, to go ahead and say that, hey, let me go ahead and have a partition which actually gives me the ranges in which you're querying. So if you're looking at 1 to 10,000, I mean like you're 10,000 to 1 lakh and then 1 lakh to 10 lakhs sort of a thing, if I'm doing it, can I denormalize this and then build the redundancy in picture over here? How many bytes am I going to store? It's very, very low. Understand that, right? So this is the concept in which you go ahead and say that, hey, denormalization starts to help you because I'm basing it based on a query pattern, right? It's the same set of data, but I'm doing it in a slightly different way, right? So in this particular case, what will happen is that you go ahead and say that, hey, give me all the population of states and cities in India which have a population of less than 1 lakh. And then I just know that I know the partition where I have to do. I don't do a partition scan. I'll do an entity scan, right? So this will be far more faster for me from doing a full table scan, right? Got the drift? I think we can start utilizing the same concept and moving forward. So I'm not going to talk about much. So understand, denormalization is not a bad thing to do. Please go ahead. I mean, I highly encourage, especially on the storage side, start thinking about it. Start thinking differently. Start thinking about, doesn't matter, what's my query pattern? And the query pattern decides on this. You could have easily told me that, hey, why can't I go ahead and put it on top of SQL Azure? Yeah, be my guest. If you're paying Microsoft more, be my guest, right? So that's what it is. So if you're putting aggregated data, then what happens, right? What if you update it? I'll come back to that. There's a pattern that I'm going to talk about. Okay, I'll talk about that. So he's asking a question which is like, what happens to the data that once it gets updated? Okay, there are different patterns for an update versus an. So the pattern is very simple. You write once, read 1,000 times. I will go for this pattern. Okay, but if you have an equal write or update intensive things, this will backfire at you. Provided you have a decoupled mechanism of doing the update. Pre-aggregation is not bad. And I'll give you a pattern for that, which I tell our customers quite a lot. Use queues for that, right? Queues is your best friend over there. Because when you update the data, put an entry on the queue that this you'll have to invalidate. This is similar to what you were doing in caching, right? All of you guys have been doing caching, right? Either be it on Redis or on an Azure cache. You're doing exactly that. You invalidate the cache and then rebuild the whole index on top of it. That's exactly what you'll be doing. Right? So that's a standard pattern that you're going to get. Okay, so don't worry on that. Okay, so as I was talking about, denormalization is good. The query first pattern is the next that I'm talking about. Okay, so what do you do? Okay, start thinking what type of queries that I'm going to do and then how they're going to perform. Okay, so in this particular model, let me just talk about it. A classic example which I've seen for a lot of customers. There are a few customers who have come back and said that, hey, I need a way in which I have transactions that are coming in. Transactions are important to me. But my query patterns are going to be of only 2 different variations. My latest transactions that are coming, my recent orders that I'm doing, I want to query them often. At the same time, I have a retention policy that anything which is more than 6 months, I don't care. Right? And I'm not going to always query based on the entity that is my customer range. Customer over a date range. I don't do that. I do it very far and few. Tell me all the customers sort of a thing which I've bought from me over the last 3 months sort of a thing. I don't do that. That's far and few. So they wanted a mechanism wherein to go ahead and say that, hey, I want to store quickly, but at the same time, I want a faster mechanism of access. So we said, okay, right, how can I go ahead and optimize this? So we took a first shot at it, and invariably this is what happens. A lot of them come back and say that, hey, take your customer ID, because that's how you're going to query it, because at some point, so I'll take my customer ID, that's my partition key. I'll take their orders, I'll just start putting it, and then I'll put a bunch of properties then when the order was done. You can have n number of properties, I don't care on that, right? So this is how I would go ahead and first design. This is an instinctive behavior for us because we come from this background, right? Now, here are multiple things that can happen, okay? Even though, what is going to happen is there are two flaws on top of this. If I have to delete everything which is more than 6 months old, what will happen? I have to scan through the whole table, right? Because I do not have that property there with me right up front. I have to scan through the whole table. That's the only way that I do. Second thing that I was asking for is that, hey, I'm going to do a customer's recent orders only. I don't care about all the orders that a customer has done at any point in time. So which means that the way in which I do my query is also going to be bad because it's going to do a partition scan, worst case, if I'm looking at a specific order. Because I don't know which customer is going to have that. I know, I want what was the what was the items in that particular order? Then I have to scan all my customers to actually find out who's got that actual order, right? So these are my two different problem statements that I'll have. So the way to look at it is, denormalizing was to club it and aggregate it. That was the first way of doing it. The second way of doing it is very simple. You go ahead and break this thing, right? You go ahead and say that, hey, I can do this. I mean, how many of you have done a partition at a table level? Yeah, either if you have done it in SQL or if you have done it in any of the other mechanisms. I think these are classic scenarios for them. Okay, when you go ahead and say that, hey, I do a partition, I do a physical separation of data set, and I don't have to worry about exactly the way in which I store it, because then my archival is never touched when my MIS system has to run. So in this particular case, I go ahead and say that, hey, you need only 6 months of data. Doesn't matter. Each month is a table for me, and I know exactly that you're not going to access across partitions, which means that I'm still performant, because your recent orders are always going to be on the latest partition. Got it? And if I have to delete when the 7th month comes, and if I have to delete my first table, it's just one full entity gone. It's far more easier for me from a delete perspective, from an archival perspective, from a query pattern perspective. Got it? Yes?
Better approach, or partition and forget the normalization. That is a better
okay
approach.
Come back to the hot partition. Your answer, you'll get your answers there. So whether do I partition it by the table, and then it's a case by case scenario. I will not go ahead and say that, okay, this one works or that one works. What happens is it's amount of data that is going to come in. Okay, like for example, if archival is going to be a requirement, then my partitioning it by table is much more of a viable solution as a thought process than if I are having legacy data with it. If you are having legacy data with it, then I will go in a different route. I would go with the denormalizing approach of that, and then that is a much more better way, because I don't have to fire and forget. That's my way. I'm not going to say that this will work for everybody. I'm just giving you these patterns. These are like solutions for problems. Now I need to understand what is your problem that you're going to solve. I'll ask you how your query pattern is, and based on that, I'll tell you go this route or the other. Okay. So let's talk about hot partitions. Hot partitions are a very classic example over here. Okay. What I'm going to do is very simple. You have a bunch of front-end servers. They're perfectly load balanced, and suddenly you see that a specific partition has got a far too much of load that comes in. Now, this load, actually, as I said, you cannot scale out on top of your partition for a single entity. But if you have multiple entities within a single partition, then I can go ahead and load balance it, saying that, hey, I'm going to split this partition in such a way that I'm going to load balance them between across partitions. So if I can split it, because now I know that D and E were put on partition 2. Now if I'm splitting by D and E separated, now I have load balanced my system. But there's a problem that you get into. What can happen is that at some point in time, you cannot scale out beyond this partition level, because at this point in time, I cannot scale out D, because as a single unit of work, I'll always be having that. Got it? So I go ahead and block myself over there. So classic examples, logging. All of us do web logs, all that, and then we go ahead and say that, hey, blob is a great storage place to actually do this, and then we just start putting it on top of a blob, either a blob or a table. Both of them have a partition out there. Okay. Now it is important for us to understand how do I go ahead and play this game, right? So the standard behavior is very simple. You go ahead and say that, hey, I'm going to create a blob, and then I'm going to have my partition key is based on a date, right? You say that today's blob is going to be on this, and then you have a row key, and then you have the properties that are there. That are the events that are coming from my systems. Now, there's one problem with this. Okay, as I said, a single partition key will be assigned to a single partition server, which meant that whenever I keep on logging my today's logging, doesn't matter which server I'm coming from, everybody is actually going ahead and pounding on a single partition server. So I do not have a scalability of my writes over here. My scalability of my writes go ahead and hit a bottom or top ceiling, and I can't do much. right? So over here, the second try would have been that, okay, go ahead and say that, hey, if I have to load balance within a day, let me just start looking at, okay, can I stream it across different servers? So instead of using a partition key for the date, I have 20 different servers. Let me have 20 different keys, which means that I'm streaming at any point in time across 20 different partition servers, which gives me a higher throughput when compared to just doing a single partition key, which is something but a hot partition. Okay, so that's the first thing that you can do. But a better way of doing this is to go ahead and batch it up. Okay, batching is your best friend when it comes into storage. So if you, instead of doing small requests, multiple round trips, if you can batch your request and then send it back to the server side, especially for things like logging or something, what they generally say that they don't want real time. I think so, you would have seen that even in Azure. Okay, the way in which we show you some of the telemetrics is based on a snapshot of time. So if you can go ahead and say that, hey, I'm going to club in every 5 minutes all the streams of data, put it up onto my blog, run an asynchronous process to actually show it to you, I'm far better off there. Okay, so batching is your best friend whenever you're playing around inside Azure. So start looking at it. Look at your partition key. It's very important. Okay, you can make a big mistake on just going by instinctive, but I would always say that whenever I sat with customers, I say that, hey customer, I just want you to tell you one thing. Whenever you start your first design, you just question saying that it is wrong. I mean, just put a googly back at you, say that, as soon as the first design has come, I said, okay, let me redesign this. And think a little bit more. As soon as you start thinking a lot more, I think so you'll get the results out. Okay? So design your applications. This comes to the point of how do you batch it, how do you do changes for data that are changing, how do I go about attacking the denormalization view. This is a very classic example. You have a bunch of front-end servers. This is something that we do. I think so all of you are using ASP.NET 4.0, 4.5, async awaits. I think all of you have done this. The only thing is that I don't go ahead and lock my thread on top of any of my worker processes and deprive my IS of doing active work. That's exactly what you're doing here. So when you get into the cloud is all about asynchronicity. And the best way that you can do is that if you can tee off a job and then forget it, you're good. And that's a classic scenario. So come in from your front end layers, put things on a queue, let it do it at the back end, and then things came going forward. So that's how I go ahead and play. The second method, which is something that I've seen for all web developers. If you are mostly a web developer, I think so this you would have started to do a lot. Okay, how many of you are using cars? Yeah, which is fundamentally that I don't want to take the heavy lifting. I'll start, especially in this world of JavaScript. I think so a lot of you are already doing it. Most of the web browsers for practical purposes for cross-site scripting will not allow you to do that. So the only way that I could have done that is giving you a shared key. Okay, which is nothing but a lease key that I give you on top of the object and directly access the object rather than pushing my whole content via my web server. Web servers, your ticking cycles are very precious. If your client can directly access a resource directly via my shared access key, you're better off because you don't go via that channel. You don't want, this is like going on a four-lane highway, and then as soon as you hit a bridge, it's suddenly like 2-lane. And everybody is coming and choking you over there. I don't want that to happen. And this is a classic example for if you're a web developer, I think so this is one of the most classic examples that you can ever get. Fair enough? Right? A lot of stuff, I mean, I'm just giving you a lot of ideas because please use it. We have seen a lot of customers start using this and they start to get a huge benefit on top of your code. So let me talk about the coding part of it. Okay, I'll talk about some of the common coding practices and then we'll wrap it up on top of it. Yeah, I know. You gave me 50 minutes. Okay, done. Okay, this is quickly on top of all the storages that you have. Okay, first thing that I've seen for the gentleman who was sitting right in front, he said that, hey, sometimes I get a temporary unavailability. Right? What do I do on top of it? If you didn't know it, primary then secondary is an option that you could have used, which is nothing but, see, most of the times I have seen that customers come back and say that, hey, do your retry logics. But retry logics are important, but you do have options which actually say that if my storage engine comes up with an unavailability, can I do it at my layer itself at the back end? Because I do not want to come across my layers to figure out that I've got something and then go back again. The costs of doing a round trip across my storage engine is prohibitively expensive. So if my partition layer can get me from an alternate secondary because of some reason my unavailability of my primary, then I'm better off. And this is a classic scenario where you would do this. Okay? Second thing, bunch of 10 tips and then we'll be done, okay? Second tip, a lot of times what has happened is I see that you start a storage account, you create a table, and for creation of a table you have a looping wherein you go ahead and say that if it does not exist, go ahead and create it. Mind you, if it does not exist, it means always that it makes one round trip to the backend. So which means that though the creation is one round trip, just to check if it is there or not is an extra round trip. And then if you write it in a big loop, you're asking for a lot of trouble. Okay, so be very careful around when especially from a table creation standpoint. Okay, don't overdo this for every round trip that you do. Go ahead and do a checking. Please don't do that. Okay. Queues are amazing, either both on the Azure queues and on the storage queues. But you need to understand one other aspect. Queues do have a lifespan. Queues do come back alive if you are not finishing during that time. That gives me the immutability of the fact that when I put something on the queue, the activity actually finishes, right? But most of the time, we don't realize that the queue's lifetime can be improved far more better. Okay, you could update your queues based on two things. Either you update it on the message content or you update it on the visibility timeout. And I have seen that a lot of customers do not touch these two. Okay, what you need to do is that you need to frequently update your queue of your message visibility. The reason is that if something has been, like for example, if you're running something for 5 minutes, and then you say that, hey, the visibility I'm going to give it is for 10 minutes, with the assumption that if my storage account goes slow, within 10 minutes it would have finished, because it's supposed to finish in 5 minutes, right? The problem is very simple. When a worker thread comes up and picks up this queue, your visibility goes down, the message is not on the queue, and for some strange reason, the worker thread died. Now, this work doesn't get completed till your 10 minutes of timeout, right? So a far more better thing for me over here is very simple, that every time I look at it, I see that, hey, I break my big time sequence that I have. When I do each activity, I just go and change the message status. I say that, hey, you have finished step 1, you have finished step 2, and then you keep a lower timeout, which means that if the worker thread at some point in time dies, then I still know that I finished 4 steps. I have to start from step number 5. And I will come back on the queue far more faster so that I can have a worker thread that will actually run it. Make sense? Yes? So play around with your messages very candidly, okay? So it's very important. Okay? Blobs. I think so this I have talked about. I don't think so I need to talk about it again. Blobs, please use asynchronous uploads, okay? Asynchronous has got, the only reason why I've seen customers being wary about asynchronicity is that they literally don't know when the blob upload would happen or when it would finish. The only way that I could have guaranteed that when it would finish is by downloading it and then doing an upload, which means that the client has far more better control. But you're losing out on top of your bandwidth. If I can do it at the server side, I'm far more better off. So if you have things that can be done in an async pattern, I would highly recommend you, please start looking at it, okay? And here's the simple thing. If you have a single blob, then upload it in parallel in blocks, okay? So you can go ahead and increase your thread count and your connection limit, by which you can actually have this larger pool. But if you're uploading multiple blobs, then go ahead and do an upload of the blobs in parallel. Okay, here's the deal. Remember, what did I tell you? I said that when you have a scalability limit on top of a single partition, which means that if you're uploading a single blob, I'm restricted by the scalability limit of that single partition. So you cannot go ahead and consume the whole resources on the single partition. So you'll get capped there, right? But if you're doing multiple files that you're doing, then the best way is that I can stream it across partitions, and that's when I'll get my streaming output a lot more faster. Right, so these are things that I normally tell our customers. Okay, so from how do you go about doing a coding and so on and so forth. So if you do, various ways in which you could go ahead and do it in parallel. So when you've done it in parallel, that I've seen a lot of times customers come back and say that, hey, I think so I've got some of these optimizations that are there. Anybody using the Nagel algorithms for upload? Have you used it? Used it? Are you using it or not using it? You're not using it. So here's the deal. Whenever you upload a blob, you have a TCP/IP optimization that you actually go ahead and say that turn off Nagel off. So if you're doing that, it's better for small workloads. So if you have small data sets that you're commuting between your blob storages, turn Nagel off. Okay. But if it's a very small workload, then at the TCP IP layer, I can look at batching. That's what Nagel does. So Nagel algorithms, I think so. There are the product team has already given you a bunch of things. Okay. So retry logics, more important. Look at geo redundancies. All that is available. All that, and I think so. I've talked about different patterns that are there. Okay, giving you an idea. Okay. So hopefully you got a flavor of what you can do with respect to storage. Storage is key. Please do have a look at it. But look at your application design. I think so. It boils down to how we access it, the way in which we actually call the request up and forth. Okay. So hopefully you got some ideas. Hopefully you will go ahead and implement it. I think next time when I come in, I think so. I hope a lot more people use the Azure storage. We do have me and Govind do have a chalk talk in the evening, which is at around 4 o'clock. I think so. We'll be doing it in the first floor. So if you want to come visit us, have a chat. I think so. We are there at 4:15 in the chalk talk side. I have my good friend Jani also doing a session around on IoT and a whole bunch of things. So please be there. We do have a session from Sandeep and Pali, who is also doing around on Azure versus AWS. So for people who are interested on top of it, please feel free go around. We are there in the conference. Catch us anytime. Ask us your questions. I think so. We are here to help you. Hopefully you enjoy this session. All these will be uploaded at some point in time. Your feedbacks are important. We cannot go without that. Please give in your feedbacks. Tell us what you want to hear from us. I think so. We'll be really happy to give you that. Thanks a lot for the opportunity, and looking forward to meeting you guys. Okay. Thanks.